So students, question 7.1, exercise question 7.1. We have to tell the center of mass of these bodies. They have uniform density, so their center of mass lies at the geometric centers. Okay, and does it necessary that the center of mass lie within the body only? No, it can lie outside the body. So this is your body, and this point, so in case of ring, this center of mass does not lie on the body. So the answer is no. So center of mass, where we assume that the whole mass is concentrated at that point. So in case of sphere, so we assume that whole mass, so this is equivalent to this, these two things are equivalent. So if the force is acting at the point C, where whole mass of the body is concentrated, and we study the motion of this center of mass, this point. Okay, so assuming it as mass means point object whose mass is m, you can, and its velocity is the velocity of center of mass, this point. So we, because these different points have different velocities, so whose velocity, I will tell that this is the velocity of the sphere. So the velocity of the center of mass will be considered as the velocity of the sphere. Second question, so in HCl molecule, so the distance between, so this is the nucleus of Cl and this is the nucleus of hydrogen atom, and they are about 1.27 angstrom, the distance between their nuclei, and you know that 1 angstrom is equals to 10⁻⁻10 meters. So we have to find the approximate location of the center of mass of the molecule. So given that chlorine atom is 35.5, so its mass is m, so its mass will be 35.5 m. Now where is the approximate location? Because here we have electron cloud. So is the approximate location of the center of mass. So we know, so we write the so this is the, suppose we have the center of mass, so there is no y coordinate, there is only x coordinate. Okay, so we assume that if this point is origin, so this is the location is x. Okay, so that's the center of mass, capital X, and what will be this location of chlorine? It is at position x. So this distance is capital X, this distance is x, and we are taking that assuming that the nucleus is at origin. So what is the position of center of mass? This x, this distance is equals to m1x1 plus m2x2 divided by m1 plus m2. So here we need not to calculate the center of mass. We were simply telling that the geometrical center, because these were symmetric bodies, but this body is not that symmetric. So we have the formula to calculate the center of mass. So I can write it as xcm also. So calculating the center of mass means telling the position of center of mass. And how will I tell its position? By telling the coordinates. If it is a plane, then I will find x and y coordinate, but here y is 0, so only x coordinate I am finding. If there was y also, so I will find the y coordinates of the center of mass with m1 y1 plus m2 y2 divided by m1 plus m2. Similarly for the z coordinate, if there is any z coordinate. So what is the position of the center of mass here? So that is m1 is m. What is x1? X1 is at origin, so its distance is 0. So that's the advantage of taking the origin at one of the mass. Okay, now m2 is your 35.5 m into x2 is this distance of m2, that is x we have taken, divided by m1 plus m2, so m plus 35.5 m. So m is actually common, so m will cancels out, and you will get 0 plus anything is 0, so that is 35.5. This x is given to us, that is 1.27 angstrom. Okay, so we can write this distance 1.27 into 10 raised to the power 10. So, but this distance is also in angstrom and this distance also in angstrom. So ultimately they will get cancels out. So value of x is 1.27 into 10 raised to minus 10. So meters divided by. So this is 1. Don't forget that I have 1 over here. Okay. So 1 plus 35.5, that is 36.5 into 10 raised to power minus 10 meters. So this also cancels out, and when we solve it, we'll get. Or if you want to write the answer in angstrom or in meters, that's your choice. This mass is in kilogram, okay, not in meters. So this is kilogram into meter, okay, this is kilogram meter. So kilogram cancels out, you are left with only meters. So it will comes out to be 1.235 into 10 raised to minus 10 meters, or you can write it at 1.235 angstrom. Okay, so that's how we calculate the center of mass of the bodies. Now the next question, exercise 7.3. So here we have a child that's stationary, that the child sits stationary at one end of a long trolley. So we assume that this is a long trolley and the child is sitting at one of the end here, and this trolley is moving with the speed v on the smooth surface. So this is the smooth surface we have, and without any friction this body is moving with velocity v. If the child gets up, so smooth floor means the frictional force, this means that the frictional force is 0. So there is no external force acting. On the system. So what is the system that we have? The system has two things. One is this child, another is trolley. Okay, so the system has two parts. It consists of trolley and the child. Now this child starts running in the trolley. Okay, and then what is the effect of the speed of the center of mass of the system? So what will be the effect of the velocity of the center of mass of the system? So students, the boy, any interaction between the boy and the trolley, the child and the trolley will be the internal force. So the force that the child is applying on the trolley by running, suppose in this direction, so it is pushing the trolley in this direction and trolley is pushing him forward. Okay, that's how we walk. So force applied by the child is equal and opposed to the force applied by the trolley. So both the forces are equal and opposed. So that is Newton's third law. So how much is the so an external force is 0. And these are the internal forces. So what is F internal? So net internal force, that is always, they will cancel out, equal and opposite. So F internal is always 0. So any interaction between the internal objects is not going to be considered. So F external is already given that there is no friction and no other force. So any interaction due to when the child is running, that is always 0. So net external force is 0. There will be no change in the velocity of the center of mass. Even if the child is running here and there, no impact on the velocity of the center of mass. Now there are certain questions in the last chapter. There was a question, same question, that the boy, he jumps into the trolley and then starts running. So as he jumps into the trolley, that will change the velocity, because here this child was not the part of the system, not the part of the trolley, but when he jumped into the trolley, then the velocity of the trolley was impacted, changed. But as he became the part of the trolley now, even if he is part of the system, and even if he is moving, running or moving here and there in the trolley, then it is not going to impact the speed of the trolley. Okay, so there is this kind of question is in the exercise of chapter 6. So next question, very important question, students. This one, we have to show that the area of triangle contained between the vectors A and B. So suppose this is my vector A and this is my vector B. Now what is the area contained between this vector? So let us join it, and this is the area contained by these vectors. So we have to prove that area of triangle contained between the vectors A and B is 1/2 of the magnitude. So we have to prove that area of the triangle is equals to half of the magnitude of the cross product. So this is our triangle. So this length is A, this length is B. So what will the area of the triangle? That's half into base into height. If this is theta, so how much will be the height? So the height is B sine theta, right? So that's the base A. So let us start from LHS. So we have to prove this. So area of triangle is equals to half into base is A into height is B sine theta. And what is A cross B? A cross B is AB sine theta. So area of triangle is equal to half. What is this value? This value is nothing but the magnitude of A cross B. Okay, so hence proved. This is what you need to prove. So simply, this is so simple. So you know that A dot B is equals to AB cos theta, that's scalar product, and cross product, which is the vector product. So this was introduced in chapter 6 and this is introduced in chapter 7. So A cross B is AB sine theta, and this is a vector. So what will be the direction? So this, suppose A, this is B, and this is, so put your fingers of right hand on A and move them towards B. So the direction of the thumb will gives you the direction. So this N is actually, this direction is perpendicular to A and this is perpendicular to B. So this direction, this cross product, that's the direction of this cross product. That is perpendicular to the plane containing A and B. Okay? So vector product. So that's why this is the so this is the magnitude of the cross product. So the area of the triangle I have written half into base into height. This is the base into height, and half into, but this is nothing but the cross product. So students, if we further extend it, this question, you can see that if A and B form a parallelogram, so we have two congruent triangles. Okay, so these two are congruent triangles, their area is same. So If I add the area of both the triangles, I will get the area of area of triangle 1 plus area of another triangle, that's equals to, so adding this, so multiplying 2 with both the sides. Okay, you can also multiplying 2 with both the sides. So what do you get? Twice of area of triangle into 2 into half into A cross B. So here that's I get the area of parallelogram. So area of parallelogram is nothing but the magnitude of the cross product. So that's the concept here. Area of parallelogram, and area of triangle is, of course, that's half. Okay, students. So what is the magnitude of this telling you? The magnitude of A cross B tells you that this AB sine theta is actually the area of the parallelogram contained by this vector, formed by these vectors, this parallelogram. So this area is nothing but this. And what is the direction of A cross B? Direction of A cross B is nothing but the perpendicular to this area of the parallelogram. Okay, so this is the perpendicular. So that direction, you can draw this direction here. You can also draw this direction here. Okay, so that's the direction of, whose direction is it? It's the direction of A cross B, perpendicular to the plane containing vectors A and B. So A cross B, what is A cross B? Magnitude is equal to the area of the parallelogram, and the direction of this A cross B is perpendicular. So here this is actually making an angle, this n cap is making an angle 90 degree with B and A. Okay. Now next question. Exercise 7.5. Here we have a parallelepiped. You can see this is the parallelepiped. This is, suppose, your vector B. This is vector A. So let us form this base. So this is your base. Now the height. So this figure that you are getting here is your, so this will also be tilted. So we are not making so how will we make this figure? This is parallel to A, and these two are parallel. This. So you can just assume this figure, parallelepiped. So students, this is the figure of parallelepiped. Okay. Okay. Now you can see that here this is the base area. Yes, and this whole angle is 90, but this angle, so this is the direction of B cross C. Okay, so this is, yes, we have just, this is the same figure. So instead of A, here I am assuming it this as B, and instead of B I am assuming is at C. So that's the means perpendicular means to this base is the direction of B cross C. And student C, very important point here, this magnitude, so this magnitude is the same as this magnitude. So the magnitude is the same because you are drawing B cross C vector over here. So if this is the area of this base is suppose 10 square units, so this is also 10 units. This you have drawn the length of this vector, because this length, the length of this vector is the magnitude of this vector, that is B cross C. So this area and this length is same. Okay, so what do we need to find here? We have to show here that A dot B cross C is equal in magnitude to the volume of the parallelepiped formed by these three vectors. So it means we have to show that this, we have to find this, and that's equals to the volume of the parallelepiped. So that's what we need to prove. So here in this figure you can see that we have considered a parallelepiped having the three known coplanar vectors, vector A, B and C, and they are meeting at the, as edges meet at point O, and we are considering OA as vector A, OB as vector B and OC as vector C. So similar figure is drawn in SL also, which is at page 7.69. Now we let this B cross C vector, it will be perpendicular of course to vector C and vector B. So it is perpendicular to this plane containing vector B and C. Let theta be the angle between A and B cross C. So theta is, this angle is 90 minus theta, and this angle is theta. So this whole angle is between B, this cross product and this base is 90 degree, and this angle is, if this angle is A is making here angle theta, so this angle will be between A and this base is 90 minus theta. Okay. So what will be the so the height of this parallelepiped? So this height is h, you can see, and this height is h. So how much is this length? So this length is A. So and this is 90 degree. So this is hypotenuse, this length A, and you are interested in adjacent side, right? So what's this is opposite side, this length, and this is adjacent. So adjacent is so open Adam open, Hari Hari Adam. So that's A upon H is cos, so A is equals to H cos theta. So this side is equals to A cos theta. Okay, so that's your A cos theta. Height is equals to H is equals to A cos theta. And now let us find this A dot B cross C. So we know dot, we have just written it over here. The magnitude of A, that is A, into the magnitude of B cross C and into cos of angle between them. So what is the angle between vector A and B cross C? So that is theta between A and B cross C. And now what is B cross C? This is B cross C, AB. So what's the magnitude of B cross C? That's A into, so B cross C is B into C into sine of angle between them. So what is the angle between vector B and C? So the angle between vector B and C is same this, but do we need to calculate it? Otherwise we need to consider this angle. We don't need this, students, actually. So we can simply know that this A cos theta is the height and this is the base area, right? B cross is base area. So base area, so we can write it as base area into A cos theta. So write A along with here. So base area into, this is your height of the parallelepiped and this is the area of base. So what is the area of base into height? So area of base into height is but nothing but the volume of parallelepiped. So hence A dot B cross C is equal to volume of parallelepiped. This is okay, students. So similarly it's just two step, telling again A dot B cross C. So A dot B is AB cos theta. So magnitude of A into magnitude of B cross C into cosine of angle between them, which is theta. So now B cross C, no need to calculate because magnitude of B cross C is the area of this base and the height is this height is A cos theta. So I'm getting it here. So this A cos theta into this area of base, so area of base into height is the volume of the parallel. So students, see, this is we call it vector triple product. So these are all vectors, so we call it vector triple product. Okay, this product we call vector triple product. So students, don't change this sequence ABC. So let this sequence be ABC only. So note it down. I am telling you the vector triple product. So this is, so the answer is volume is scalar. So that's scalar triple product. Let me just note it down. I'm telling you this product thing. So students, this is a scalar triple product. Vector A dot B cross C. Sequence is not supposed to be changed. A, B, C, then A, B, C. Okay. So if you want to start from B, then it will be B dot C cross A. If you want to start from C, then it will be C dot A cross B. So you will get the same answer. So that is the volume of the parallelepiped. So only cross product, magnitude of cross product. So magnitude of cross product is the area of the parallelogram contained by those vectors. Scalar triple product is the volume of the parallelepiped formed by vector A, B, C. So we can write them in any way. Okay. So this is not the vector one, this is scalar triple product, because we are getting this answer volume as scalar quantity. Okay, so that is why we call this as dot product or scalar product, because scalar product we are getting the quantity as the resultant as scalar. So here this is cross product or vector product A cross B, because we are getting vector as the resultant. So I hope you have noted it down. Students, any problem? Shall I move forward?
Yes.
So exercise question 7.6. So exercise 7.6, we have to find the components along x-axis, y-axis and z-axis of the angular momentum of a particle whose position vector is r, with components x, y, z, and momentum is p with components px, py, pz. So it means what is given to us is that this momentum, angular momentum vector, is this Lxi cap plus its component in y direction plus its component in z direction, and then we have the position vector r whose components are xi cap plus yj cap plus z k cap, and then we have the components of the momentum vector, that is pxi cap plus pyj cap plus pz k cap. You know that I cap is the unit vector along the x-axis, j cap is the unit vector along j-axis, and k cap is the unit vector along z-axis. So that's k cap. Okay, so multiplying their magnitude with the direction and getting the vector. Now, what we have to show, that if a particle moves only in the xy plane, so if particle is moving in the xy plane only, so that's your xy plane, so particle is moving only in this plane. Okay, so it means what will the coordinates over here? So the coordinates will be x coordinate and y, and what will be the z coordinates? Z coordinate will be 0. So z equals to 0 here. Okay, so this z equals to 0. So that's the first thing that we need to notice. Now, what about its momentum in z direction? So of course, if the particle is moving, its velocity will also be in this plane. So its momentum, its linear velocity, so its linear velocity is in this plane, so in the xy, so momentum in the z direction will also be 0. So pz will be 0. So now we have to show that if the particle moves only in xy plane, so this is the result of the particle moving in xy plane. So it can be linear motion, it can be rotational motion, any motion is there, but the momentum, as there is no velocity vector along the linear velocity vector along the z-axis, so pz is 0 if the motion is along xy plane. So we have to prove that angular momentum, this is your angular momentum, has only z component. So this is what we need to prove, that it will have only this k cap, only Lz, and this they will be 0. Okay, so we have to prove, to show here that this is equals to this Lz k cap only. So this is what we need to show. So let us find L. What is L? So the solution, what is L? So L, so we have 3 cross product, students, here in this chapter. First one is V is equals to omega cross R. Second one is tau, that is torque. Rotational force, that's equals to R cross F. And the third one is this angular momentum, and that is R cross P. Okay, so these two are important, and here V is equals to omega R perpendicular. Here also tau is equals to R perpendicular into F, and this one is also L is equals to R perpendicular into P. So in terms of magnitude, you can write it like this. So L is equals to R cross P. So now how do we calculate this cross product? So we have, we need to write I cap, j cap, k cap. Now write the components of R in the second row, that is x, y and z. Now write the components of P. So components of P are px, py, pz. Okay. Now what will be the value of this? So that's equals to, see, this is a vector. So of course I will have 3 components over here, I cap, and then 1 component plus j cap plus another component k cap. Okay, because this is a cross product, this is a vector product. Okay, so how will we find the I cap? So just put a line over here, and then y into pz minus z into py. Okay, so this way, students, you need to write. So y into pz minus z into py. Now this sequence should remain the same. So if I want j cap, so this is x, y, z, so again I have to write x, y, z. Okay, and px, py, pz. So that's another way of understanding it. So we need to find, so this again I cap, k cap, and I cap, j cap, and k cap. Okay, so now what about this j cap? So j cap, remove this, and this is equals to zpx minus xpz. Is this clear? zpx minus xpz. Okay, so zpx minus xpz. So it's so simple, students. Now k, so let's move forward. So keep on moving forward. So x into py minus y into px. I hope all of you have understood how to write it. So this k cap, this I have removed. So x into py minus y into px. So is this clear to everyone how to write it down?
Yes, sir.
Good. So now just you don't need it. This is just for your understanding, so just remove this part. Okay. Now and there's another way also. You write negative sign here, so if you are taking suppose j, then you need to start from this way, this minus this. So you can do this also. So earlier on, in case of I, you were starting with this manner, this minus this. Okay. So in case of j, not starting from x but starting from z, and then this. And in case of k cap, same manner as I cap. So this minus this. Okay. So in any way you can remember it. Okay. So lot of ways some of the people also do, like when they are choosing j, they are writing here minus and this minus this. So putting minus sign over here, you can write it as xpz minus zpx j cap, right? So xpz minus, so but you need to write here minus, so this minus will go inside, becomes plus, and we get the same thing. So students, you can see even if in the video I have told you all the three methods that people use to calculate this. So this determinant form, we call it determinant form, how we are writing it. Okay, now you know that as the particle is moving in xy plane, so z is equals to 0. So this z is 0. So this term will cancel out. This z is also 0. So this term will also cancel out. Pz is 0. So this Pz is 0. So this term will also cancel out. This Pz is 0. So this term will also cancel out. So hence you can see that L is equals to x py minus ypx into k cap. So this is what we need to prove, that the angular momentum has only the component along the z-axis. Okay. So this thing is your Lz. Okay, students. Shall we move forward? Yes, note it down. Note it down, students. Noted it down.
Done, sir.
Okay, good. Okay, good. Those who are left, just note it down. हाँ. क्या कह रहे
Sir, your screen is present.
Okay, next question, students.
Sir, your screen
Your screen is not active.
Yes. Your
Sir, screen is not visible to us.
screen is not visible. Okay, sorry. Okay. Now the screen is visible, okay?
Yes, sir.
Okay.
Yes, sir.
Okay, noted it down. Okay, let us do one more question based on this angular momentum. Next question, exercise question 7.7. Okay. So students, here we have two particles, each of mass m. So they have the same mass and same speed. So let us see. But here we have this this x-axis, this is y-axis, and we have the two particles as so this is the first particle m1 and this is another particle m2. So they have same masses. So this m1 is also m and m2 is also m. So they have the same masses and they are moving with same velocity but in opposite direction. So their speed is same, but they are moving in opposite direction. So let us assume that the x coordinate of the mass, this first mass m1 is x and the distance between them is d. So they are separated by a distance d. We have to show that the vector angular momentum of the two particles is the same whatever be the point about which angular momentum is taken. So the angular momentum does not depend on this x. So angular momentum is independent of x. Okay, this is what we need to show. So we can take the origin anywhere and we'll get the same answer. So this is what we need to prove. Okay. So both the particles are moving parallel to the y-axis here. So what is the total angular momentum of the two particle system? So total angular, so that's the solution. So total angular momentum of the two particle system so you are going to take the momentum about O, okay, about O is L is equals to, so adding the momentum of both the particles will be the total momentum of the system, and that is equals to, what is L1? So L, we have just written that L is equals to R cross P, right? And this is you can write it as R perpendicular into P into, so if you are writing the magnitude, so that will be sine of the angle between R and P. So L1 means R1 into, so if you are writing here perpendicular, you need not to write this sine theta. So if you don't want sine theta, then only you need to write so the magnitude of R into magnitude of P into sine of angle between them. But R sine theta is actually R perpendicular. Okay, so that's your choice. So how you are writing it, this way or this way. So this L is R1 cross P1 plus L2 is R2 cross P2. Now what is the magnitude of R1? So R1 is the distance from this distance, the perpendicular distance. This is your the axis of rotation you passing through O. So about O you are taking the angular momentum. So from O to this, so if force is acting in this direction, suppose this is the line of action here, the velocity is in this direction, and this distance is your perpendicular distance, and that's x. So this is x. Or you can do one more thing, put the value of r1 here. So what is r1? That is xi cap, magnitude into direction, the position vector, this position of this, and then into momentum. So if this direction are taking positive, so this direction will be negative. So this velocity will be minus, this direction is negative direction. So, or keep writing the magnitude v, so mass into velocity, so m into v, but this direction is suppose j cap, then this direction will be minus j cap. So this into minus j cap plus. So I'm just putting the values of, and what is r2? So r2 is x plus d into I cap plus so that's m into v momentum. So they have same masses and same velocity, and this direction is plus j cap. So just putting the values. Now that's equals to, so these are the magnitudes, constants, they will come outside. So x into m into v, and minus sign is over there. So minus x into m into v into I cross j cap plus, similarly here, so this is x plus d into mv, and I, this is cross, student, this is cross, so cross j cap. So that's, so we can write it like this. So what's this equals to? So I cap cross j cap is I, so that's the common, so minus xmv plus this is mv into x, and this is mv into d, and into I cross j. So this will cancels out, and you are left with that's equals to, so this angular momentum of the system will be equals to mvd, and what is I cap cross j cap. So students, look here, this is, write it in sequence, I cap, j cap, and k cap. So I cross j, so here also you can see this I cap, this is j cap. So magnitude of I, that is 1, magnitude of j, that is 1, and sine of angle between them, so the angle between them is 90 degrees, so sine 90 into direction of I cap cross j cap, that's perpendicular to this plane, so that is z axis, so that direction is k cap, so into k cap. So this becomes 1, sine 90 is also 1, so I cap cross j cap is equal to k cap. Similarly, so write it in sequence, so j cap cross k cap is equals to I cap, so I cross j, j cross k, and k cross I is equals to j cap. Okay, but if you change its sequence like j to I, then it will be along minus k, and k cross j is equals to minus I, and I cross k is equals to minus j. Okay students, so I cross j is this thing, that's k cap. So that's, we have proved that this momentum has only the component in the k direction. So here this is there's no role of x here, no role of x, only the distance between the particles matter, but where you are taking the origin it doesn't matter. So x is not the part of the solution, so L is independent of the x. So hence L is independent of the, so you need not write x, you have to write the full sentence which is written in your book. So L is independent of the point about which the angular momentum is taken. Okay, so students, note it down. See, these things are additional things. This like this thing is the additional thing. That's not the part of the question. That's just for your understanding. So you can write them separately as note, this part. This also note. This you can write here because L is equals to R cross P. That's not. So that's all for today, students. Tomorrow morning your class will start at 6:45.